In this tutorial screencast, we're going to look at the nomenclature of alkenes, and we're going to specifically look at a molecular formula of C4H8. The first thing we want to do is use the saturated alkane formula of CnH2n plus 2. Our n is equal to 4, so we have 2 times 4 plus 2. So for 4 carbons, we should have 10 hydrogens. So to determine the degrees of unsaturation and what we're given, we just subtract. So we end up with H2. A molecule of H2 is a degree of unsaturation, so we have 1 degree of unsaturation. And for this screencast, we're going to specifically limit our functional groups to alkenes, so that degree of unsaturation is going to be a pi bond. So what we're going to do is now propose constitutional isomers of C4H8 and then name them. We want to be methodical on how we do this so that we determine all the possible constitutional isomers. So we'll start off with C4 chains. And when we draw that, we have a C4 chain. I want to put numbers in now so that we can see how we're going to put the pi bond into that system. 1, 2, 3, 4. Let's go ahead and put the pi bond between carbon 1 and 2. So the name of this molecule is going to be 1-butene. So notice, as opposed to an alkane, which ends in ane, an alkene ends in ene. And so the 1 is basically specifying the location of the start of the alkene. So it's between carbons 1 and 2. So within the C4 chain, we can also put the pi bond between carbons 2 and 3. Let's go ahead and do that. So now we're going to have a 2-butene, but there's also another thing we have to consider in naming this molecule. And what I want to do is go ahead and show the other possible constitutional isomer so that we can see comparatively why there's a difference between these. I'm going to draw the C4 chain slightly different this time. I'm going to go ahead and number it. 1, 2, 3, 4. And I'm going to put the pi bond in the same position between 2 and 3. And what you'll see now, if I go ahead and add the hydrogens into the pi bond here, that in each of these molecules, the hydrogens have different relationships, or alternatively, the methyl groups have different relationships. So they're both 2-butene derivatives. So we need another nomenclature rule to specify that they are different. So what we are going to do, and I want to highlight this, each sp2 hybridized carbon, so I'm highlighting them in blue, you have to determine a priority rule. And basically we're going to look at the atomic number of the 2 substituents on each sp2 hybridized carbon. So in this case here, for this sp2 hybridized carbon, we're comparing a carbon, CH3 group, versus a hydrogen. So the carbon is going to take higher priority over the hydrogen, so I'm going to put a 1 here and a 2 there. Now I'm going to do that on the other sp2 hybridized carbon. So we have a 1 and a 2 for that hydrogen. So all we're doing for each sp2 hybridized carbon is comparing the priority rule, or atomic number basically, of the substituent bonded to that carbon. So you can see the 1s are on opposite faces. So what we have to do is then specify that in the name. So before the 2-butene, we're going to put trans. So trans in this case means opposite. So this we have trans 2-butene. Now if we do the same sort of analysis for the other molecule, I'm highlighting in blue the sp2 hybridized carbons. I analyze both substituents, carbon versus hydrogen. I give them the priority ranking. Carbon's going to be 1. This hydrogen's going to be 2. I then do that for the other side. We have 1 and 2. You can see now that both of these 1 groups are on the same face. So in that case, we're going to put a cis in front of the 2-butene. So we have 1-butene, trans 2-butene, and cis 2-butene for the C4 chains. So let's go back down to the C3 chain. Now again, we're going to draw 3 carbons. I'm going to number them 1, 2, 3. So I'm going to put the pi bond between carbons 1 and 2. So this is going to be a propene derivative. And so now we still have that last remaining carbon. And really, there's only one place we can put it at this point. We can't put it at carbon 1 because that would make either trans 2-butene or cis 2-butene. We can't put it at carbon 3 because that would make 1-butene. So the only place we can put it is between, or is at carbon 2. So at this point, we're going to name this as a propene derivative. So we have a substituent, a 2-methyl group, 2-methyl propene. And what I want to point out here is if I draw both of these hydrogens in, notice that this hydrogen sees a methyl and that hydrogen sees a methyl as well. Since they both see the same group, we do not have to specify cis or trans. And notice as well, I didn't have to specify the location of the alkene. If it's not specified, you can assume it's starting at carbon 1. So if you wanted to be very thorough about it, you could name it 2-methyl -1 propene. So in this screencast, we've looked at the nomenclature of alkenes for a C4H8 isomer, and we've determined that there's 4 constitutional isomers that we could draw for these. So as a challenge to yourself, you can determine the unique number of carbon So that's the carbon and proton NMR experiment. And also at this point, determine pKa of each type of CH, and then rank them from most acidic to least acidic or vice versa.